My name is Ben Yuri, and today I will talk about a self-updating model of COVID-19 mechanisms. The self-updating model is part of a framework called the Ecosystem of Machine-Maintained Models with Automated Analysis, or EMMA. The main idea behind EMMA is to monitor the scientific literature and using text mining, extract knowledge as soon as it appears, then assemble this knowledge into one of several models that are being built using new literature results. EMMA then assesses the effect of this new knowledge by modeling each disease mechanism and checking whether the model, given new knowledge collected on any given day, can explain any new experimental findings. It then notifies users about new findings that it concluded. Users can also register their scientific questions and receive email notifications about novel results. So EMMA is available at emma.indra.bio, where you can see multiple models maintained by EMMA, including ones that are built around specific diseases and ones that are built around specific signaling pathways. Looking at the COVID-19 model, we can click through to its details to arrive at this page, where you can see the various details of this model, its description, when it was last updated. You can link out to a network view of the model through the Network Data Exchange website. You can see some summary statistics of the model, the types of mechanisms that are involved, for instance, activation, complex formation, amount regulation, and so on. You can see the top entities that are used in the model, including TNF, inflammatory response, and so on. In terms of the sources of the model is largely built out of text mining from the scientific literature. And so there are several text mining systems that are listed here as sources of knowledge, in addition to structured sources such as the Comparative Toxicogenomics database, as well as VirHostNet or DrugBank. The list of most supported statements shows you which specific mechanisms have the most support from the literature. And this graph indicates the number of statements that were learned each day from the literature. So we see a steadily increasing number of statements here as new facts are collected from publications. Each day, the list of new added statements are shown here. These are an English language view of these statements, and one can click through for each of these statements to look at the underlying literature evidence, link out to the given publication, and submit curations if there are any incorrect findings. So each of these models is not only built and updated daily, but also tested against a number of experimental observations. And currently, the COVID-19 model is tested against a set of drug experiments that were done in vitro to see which drugs can inhibit the replication of SARS-CoV-2. And they are also tested against a set of observations about possible drug effects on a number of different coronaviruses. And this test corpus contains about 2,000 test conditions. So this is an example of an explanation found by EMMA for one of these drug virus effects. In this case, how proceleridin inhibits SARS-CoV-2. And the explanation found by EMMA here says that proceleridin activates AMPK, which in turn activates NFE2L2, which inhibits SARS-CoV-2. And again, we can click through to see specific evidences for each of these links along this path and the underlying publications. Another important feature of EMMA is the ability to query models. When we click on the Queries tab, we arrive at a page where we can select multiple different query types. And I'm going to demonstrate the Open Search query on the COVID-19 model, where you can select a type of interaction or a type of effect, for instance, inhibition, a target, for instance, COVID-19, select the direction of the search. In this case, I'm going to search for upstream regulators. And you can select types of entities that you want to search for as possible regulators. And I'm going to select small molecules. And when I click Submit, I will get results for all the small molecules that are directly or indirectly known to inhibit COVID-19 in this EMMA model. There's also a checkbox for subscribing to this query. And when registered and logged in, if a user subscribes to a query, they will get email notifications every day if there is a new result based on what Emma collected from the scientific literature for a given query. And these emails then link back to the Emma website where the underlying evidence can be inspected. The query is now complete, and we can look at the results for this query on this page. And what we see is a list of drugs that have been shown to either directly or indirectly inhibit COVID-19. All our results related to COVID-19 are available at the covid19.inra.bio website. This website describes our self-updating COVID-19 model that I just introduced, as well as the results of aligning our models with the COVID-19 disease map effort. And the results of this alignment are available here. And as you can see, we found a total of 656,000 INDRA statements that contain at least one member of the COVID-19 disease map entities, and 40,000 INDRA statements that relate at least two members of the COVID-19 disease map. And these results can be used to find additional evidence for existing reactions in the disease map, as well as suggest new relationships that haven't yet been curated in the disease maps. And finally, statistics from these statements can be used to focus the curation efforts on things that are missing from the disease map but have high support in the literature.